Hello and welcome. I'm Bill Wake. We're working on a program to compare tunes for similarity, and we're doing that with a clustering algorithm. And the way we're going to display the cluster is with what's called a dendrogram. Once we put in real data, we found out, we made some mistakes in how we processed our dendrogram, or how we drew it. And I'll get to the picture in a moment, but basically we have a line that should center on the diamond, but it's centering on the range of rows. So let's see. I think I have a test case that should demonstrate it. So here we have 4 in a row. These two are the most similar. Then this one is most similar to those, and then this one. All right, so the first bracket, this one, connects 0 to 1, and the diamond goes at the 0.5 mark. All right, now our intent is the branch, the horizontal branches should connect to the diamond or an element, not somewhere else. Okay, so the other place we've been putting things is we've been putting them in the center between of a group of rows. So between 0 and 1, there's 1/2. Between 0 and 2, there's 1. 0 and 3 is 1.5. Okay, I believe this is the way we want this to work. So 0 to 1 is 1/2. Okay, well that's the same in both situations. The diamond should be drawn here, halfway between 1/2 and 2, which is 1 1/4. Okay, so the diamond gets drawn there, and up to this level, there's I think our program is working correctly because it uses the rule for diamonds. Okay, and the branch, it didn't matter which one it was, but the next one, I believe, is going to go wrong. The diamond here is at 1 1/4, and then the row, the element is at 3, so that should be half of 4 1/4, which is 2.125. Okay, now if it's drawing the diamond there and appropriately up here, but I think what it may do is it may say, well, this diamond covers the range 0 to 2, so half of that is 1, and so I think it's going to draw the line at 1, even though the diamond's at 1.25. And then I think our diamond drawing is right. So the problem we have, or at least my understanding of it, is we're drawing the diamonds with one rule that says split the difference between the two lines, and we're drawing the line with a rule that says center it on the range of things you cover, not on the range of the center of the previous connector. Okay, so you can't detect that until you've drawn the second line. Okay, and in my mind, I didn't think there was. I didn't consciously make a difference. So, I may have thought they were the same. Who can say at this point? But I don't think they are. And 2 nodes is not enough. 3 nodes is not enough. I think, but when you draw the 4th node in the top line, now you have 2 lines, and we can see a difference between them. The first one, because 0 and 1, the center is the center regardless of which approach you're taking. Okay, so let's see. Connector tests. I know we have those open. Okay. All right, now we had the way we did this. We've got we've got a few tests on this stuff. Yeah, it's interesting to me that this slipped through. Okay, it's definitely a flaw in my testing. All right, let's get back up to the first cluster. Okay, element cluster has no connector. Okay, that's a rule we have so far. All right, cluster with 2 components. Well, 1 and 2 don't make a difference. So, it's going to draw to 0, line 0 and then line 1. All right, 2 clusters with connectors. Okay, so we have 1 and 2, then 3 and 4 connects 3 and 4, and then 5 connects the other. Now, connects 4 and 3. That sounds a lot like what we want. Okay, maybe we didn't check enough things. I'm thinking that's the case. All right, so I think this is analogous to our first case. I'm going to number these back to 0. The first element is the sequence number, and we are starting 0 based. So the test can do anything, it can make up any numbers. For most things, they're arbitrary, but in our case, they kind of correspond to row numbers as well. Okay, so C1 and C2, and then C3 and C4. Okay, if I go back to this, that's 2 clusters, 2 connectors. That's not deep enough to trigger this problem. Okay, so regardless, we'll skip that. Okay, flipped cluster, I don't know what we're flipping. Oh, a similar cluster, but with different nodes connected first. Okay, that's not going to matter. A balanced cluster. Now, this is the one we used for our demo data for a long time. Let's see, do we check 2, 3, 4, 5 connectors? Okay, let's see if this one, So we got 1, 7, 8, 10, 11. So the node 8 and 9 cluster, C2, C3. I guess node 11 cluster should... Okay, this is row 0. Do I dare? Let me run this. I think I just changed something that might have mattered. These numbers show up in the tests as well. This should be 0, 1, 3, 0, 1, 2, 3, 4. Slow building. I don't know why that line keeps complaining. Let's delete it and put it back. Okay, 2 failures. Connector tests. Right, this should be 1 off. 0, 1, 3. Zero, 1, 2, 3, 4. Test should be a bit faster. Okay, now I'm going to do the same thing here. Get this 0 based. Okay, so these element IDs should be 1 less than they are. 0, 1, 2, 6, 2, 3, 7. Four, 5, 8. Oh, well, 3, 4, 5, 6 should be 2, 3, 4, 5. 8, 9, 10 should be 7, 8, 9. 2, 4, 5, 6, 7, 8, 9, 10. Okay. Well, I messed up something. Oh, I got the IDs wrong now. They should also be one lower. 83, 94. Same thing down here. ID 6, 7, 8, 9, 10. Okay, well, let's, we are update IDs in tests, so they're 0 based. Now, I don't know that, well, it surprises me 2, 4, well, that's kind of a balanced one. Okay, I guess we're going to write a new test. Center of line is center of diamond. Okay. Well, we got element 0, 1, 2, 3. Which will be something like this. I'll switch these to zeros. Element, well, 0, 1, 2, and 3. Okay, so 0, 1, 2, 3, that corresponds to these elements. Then we need a cluster. I'm going to call it C01. Okay, we'll call this number 4. And it's got E0 and E1. Okay, E0, E1. And that's kind of arbitrary, but we'll do it. All right. So that's, whoops. That's the first cluster, this one. And then the second one is 0, 1, and 2. Call that 5. 0, 1, 2, 3. That looks fine. 5. Let's make it 0.8. He clusters C01 and E2. And then we have 0, 1, 2, 3. It's cluster number 6. Let's make it 9, 2, 5. And he's 0, 1, 2 and E3. Okay. Now we got to assert. Okay. Well, I don't want connectors. Let's see. Do I need to do it like this? Right. Okay, so there should be 4. Well, no, there should really be 3 connectors. 0, 1, and 2. We'll take this out. Okay, and I think we want to say, okay, this is ID 4. Oh, I didn't get actual yet. Okay, ID 4, 5, whoops, and 6. ID. Okay. Now the contents, cluster 4. Cluster node 4 contains E0, E1. So that's 0, 1, and 4. Okay, his level 0.75. I'm gonna make this we'll see. We need some fuzz on the check. All right, so his cluster 0, 1, 4.5. Y is 0. I'm assuming length is the same. Y is 1 for the second one. So this is node 0, 1. They're in order, so that should be fine. All right, now ID 5 contains 0, 1, 2. So this should be 0, 1, 2. And it's going to contain 4. And it's going to contain 5. This should be 0, 1, 4, 0, 1, 2, 4, 5. So we had 2 and 5. The branch height for the top one, okay, we said Y would be 0.5. Length 0.8. Well, this one's length is 0.8. This one is 0.05. It's this one already drew the 0.75. So to get to 0.8, we need 0.05. Okay. Now element 6 should have everybody. 0, 1, 2, 3, 4, and 5, and 6. Is that right? ID 6, 0, 1, 2, 3, 4, 5, 6. Okay, he has everybody. His bottom branch is 0.9. His top branch should be from the center. Oh, have I done? Okay, he's 0 and 1. He's 0.5 to 2. And this should be y equals 3. But the halfway point for this one is between 0.5 and 0.2 is 0.125. Make sure that looks right. 1.25. Okay. Now, we put in a sort of trial implementation. I think it's going to say it's going to pass. Otherwise, we'll double check all our numbers. So we're really checking these two lines. They asked me yesterday this time too. Okay. All right. Not everything is right. Okay. Yeah. Okay. I got to choose numbers that are powers of 2. All right. Let me do that. 0.875. And that adds 0.05, which is not exact. 0.875. I guess we could do 1.0. Okay, so I've got to recalculate these lines. These levels. Okay, 0.75, that's fine. This is 0.825 minus 0.75. What is that? If you had 0.075, does that work? 755. 5 is 12, carry 1, so 825. Okay, I think that's right. And this one, the length is 1.0. And this distance is 1 minus 0.825. So that's 0.175. Is that right? 1 and 9, 9, 5, 1.0. Okay. I think I've chosen numbers that add up. It may, I don't know, about 0.175. Okay. Okay. .875. Okay, I wish I could move this. Element 5, element ID is 01245. Level 875. Top 0.75. Oh, my X's are wrong, aren't they? Okay, so this branch has to pick up where this one left off. His length was 0.75, so his x should be 0.75. So his length takes him to 0.825, yes. Okay. This one, it left off at 0.825, so that's where this should pick up. And was there 0.175? I wonder if I calculated that right. Top 0.4175, top 0.875, 1.25. Y is 4. I don't know, I think I'm doing something wrong here. 0. Okay, there's 0, y is 1. There's 1, y is 2. 2. I don't know what this one is. This one should be 3. And then maybe this is 1.25. Go to our picture, 1.25. Okay, so the top line should be 1.25. All right. It's so hard to get all these little twiddly numbers just right. Oh, okay. Alrighty. Where are we going wrong? So 5, element IDs, level 0.875. Zero on 245, level 0.875. Well, that should be level 5. That cluster should be level 875. Okay. This one should be level 1.0. All right. What else? Okay. Let's see. 875, 0.75, 0.5125. That should be the difference between the level and the length. And that is 0.125. And now this one, the length should be 0.875. Right? It should match. It's the standalone node, so it should match the level. Okay. This one, the level should be 1. This should be the difference between 875 and that is 125. Element IDs. Okay. 0, 1, 3. Oh, come on. All right. Well, that one's good. All right. How's this last one? All right. ID 6, element IDs, all of them. Level 1, top is 875, 125, 0.125. 8. Oh, it should be the same as the previous length. Yes, 875, 125, 0.125. This one, X is 0. It's the whole length, line 3 and length 1. Did that come out right? 0, 3, 1. Okay. I'm getting there. So bad when you take so many tries to get the test data right. It's like, how much confidence do you have again? All right. Let's have that green bar. All right. Okay, so create test data to show upper line connects to previous diamond. Okay. Center of previous connector. All right. Now this test is passing, and the reason it's passing is we put in an implementation yesterday. It's an awkward implementation, but I'm gonna take it back out. Oh, we want connectors. I'm gonna take it back out, and then we should see that test fail. All right. So it was this calculation of center 1, center 2. Okay, so the top one's the original, and the bottom one we wrote, which is really awkward, but I mean, it's an awkward way to do it, but we got there. I'm going to run the test again, and that test center for whatever we're looking at on the left there should pass. Sorry, should fail now because we got the wrong center. Okay, good. Let's see, where's it failing? Yeah, we expected the last one to fail with this 1.25. We think it's going to come back with a 1. All right. 1.25 is Y on the top branch. Branch top Y is 1.0. So it just averaged the lines 0, 1, and 2, got 1, instead of averaging the connectors 1.25. All right. That lets me delete this code because we know it is wrong. Okay, it's a little bit of a backdoor way to do your TDD is, you know, get it right and then go force it to be wrong and then test it and make sure it really was wrong and all that. But we'll take it. Okay. Now, I think a consequence of this, I kind of wonder if this method is called anymore. I think it might not be. It's containing center. Okay, let's look for text containing center like that. They're only tests for connectors. Okay. So let's push what we got because it rained green. Delete unused commented out code. Yeah, so I wrote a test that was correct with our sort of trial code, and then I wanted to make sure that the test would fail under the old regime. And now I know it did, so I deleted that old regime, and we're back to this somewhat awkward but working implementation. All right, and I'm refactoring now. I'm saying nobody uses this except some tests, so let's take this out. The tests should complain. Well, we know where they are. Okay, so this is the cluster connectors center method. And that one. Okay, so I think that connectors.center. Okay. And test should pass. I'm going to sleep here. Okay. Well, I don't need those in 2 places. I think these were probably done with. I don't know. Wow, it's like my machine's frozen. The video's still moving? I don't know. Okay, there's the testing. All right, so remove dead code connectors.center. Okay, now. So I think, well, clearly we've got duplication here because of these two being so similar. But I also think let me pull up cluster. Okay, so our cluster, we made it an indirect enum because the cluster either points to an element or a cluster, a couple of previous clusters. What we've done with connectors is we've just shoved them in a list. I mean, I guess, well, connectors, where's a non-static method? It just contains a list of connectors. So we're treating it like an array. And what I think I'd like to do is make cluster and connector be parallel, that a connector contains previous, sorry, let me get the connector in here. The connector, I almost want it to point to those. I want it to be a parallel structure to the cluster structure. So in effect, I want to have, like the cluster has two children, I want to do that for the connector. And then when you want to go from one connector to the other, it's very straightforward. So I don't know if, I don't think it's going to make things worse. What the other thing that occurred to me was the cluster, they put the elements, I mean, the elements are the leaves. In here, the connectors are leaves, but it almost makes me wonder in our running app if maybe those elements should be there. Let me get an example up here. So this cluster, all right, well, notice it does look better, all right? The lines are connecting to the center diamond point, not arbitrary other places. All right, that much is good. But this, right, we're managing this as a totally separate list of things. Like, why not put it in the have leaf connectors that just have those fields in them, and let them be responsible for the name, and then drawing them is no different than drawing anything else. So it's a moderate change. I mean, we could put them in and then not use them in drawing for a little bit. Would be fine. But I think if we put them in, I think it makes things better. All right, let me open the big one just to make sure our change improved it as well. It's going to be harder to see because it still has that sort of horizontal overlap. But yeah, it looks like every horizontal line is connecting in the center of a diamond. Yeah, that one's part of this. It got overwritten. They still overwrite each other because the horizontal distance isn't broad enough. But I'm happy with that. That got us through that problem. Okay. So the reason I'm wanting to do this, let's see, in connectors here, I'm going to the trouble to get the connectors. I get the set of connectors, and then I dig around until I find the one I want. Well, really, that should be the first child of this thing, and just look at it. Same for this one. I get another set of connectors and dig around to find it. And then in here, well, I don't think that one matters so much. But again, he appends to an array with the new cluster. I really could just return the top level connector, and I would have enough information to draw the whole tree. It would just be all in the connector instead of in this array and the connectors. Is it the most important thing to do? Well, partly I guess I get to choose that, but I think I do want to do this because this all feels like we're doing the same thing twice, and then sort of pulling results out to do more. So I think it would be better. I think I wish I had done it that way in the first place. I don't know. The list of connectors, it's really kind of odd to me. So what that means, the list of connectors, dendrogram view, it's doing this Z-stack. These clusters, they could be in random order. Well, we know there's a little bit of Z ordering to make sure that the right one wrote on top or whatever, but they mostly don't matter. They're being drawn relatively independently. They're in an order because of the algorithm that we use to cluster things. They kind of come out in a particular order, but it's not really treated that way. It's a Z-stack, so there are a bunch of things in layers, but they all get drawn. Okay, so I think I want to do that. Now, the way I'm going to do it, I'm going to leave them in the array. Basically, I'm going to get them all connected up first, and then look in the array and make sure they're and then switch from using the array to using the leaf node or the root node. Okay. Now, this name may not hold. Okay, so cluster, you pass in a cluster in a starting row and it produces the clusters full list of connectors. All right. So let's work on the data structure first. All right. So I think well, if we're going to have an indirect struct like cluster, okay, it's going to be an indirect enum, and then all this stuff, well, we have a lot of fields in here. I didn't like it with 5, but now I've got 3, 5, 6. One's computed. And I also want to have connector 1 and connector 2, so it's going to be 7 or 6. It's too much. So I think what I want to do is have a connector info that has all this stuff. Yeah, I think I want that. So let's make this connector has E, but nothing in here is related to E. So I think that can go. build. I'm liking that. Okay, let's make sure everybody's happy. Oh. Well, that's not right. Contents. Okay. Well, okay. Make connector no longer generic. I don't know. Maybe at one point we're going to put the values instead of just the sequence numbers in. All right. Now, I'm going to do this. I'm going to make this connector info. And then I'm going to make a new struct connector, which is equatable, identifiable, and hashable. Okay. Do I need it in there? Well, I don't want to do that. Info of connector info. Okay. And his ID is of type sequence number is just going to be info.id. Okay, so I'm saying the info has the ID in it. I might move that out in a minute, but just to get simple changes. And everything else is in the info. So anybody who puts stuff in these fields is going to have to update to use info now, and the compiler should tell us where all those are. Okay, connector has momenter center. Well, that one we can fix. Connector. Okay. I guess I could do an init. Reference to static method build selected. Connector.id, that seems okay. No exact matches in reference to static method build expression. Connector. Connector.id should be okay, that we inherited identifiable. I'm not sure. Selected elements. Set events. That shouldn't be a problem. Static method build expression. So usually that's messed up when it's a view, so it's, you know, something's messed up in your view structure, but this seems legit. Connector.info. Right. Info.top. That seems okay. Oh, we're passing branch. Make sure we're doing that. Info.top is a branch. Connector has no element IDs. Okay, that should be info. Okay. That message is often hiding something else. I think it was here too. Okay, so some tests probably need this new structure. I mean, almost would have to. You know, I don't like doing this. I'm going to give connector I don't know if this will hold up, but I'm going to try giving connector a constructor that builds the info item. And it seems like you're specifying just about the whole connector anyway, so I don't know if I feel like passing all those is going to help much. Let me try a better constructor. So I think he's going to be he's going to be this. Okay, if you did this, I think we can say self.info equals connector info that. And now the diagram view can go back to that. Oh, it was connectors. Yeah. So he's creating that. I mean, I could give access to all these, but it's going to get worse when the indirect stuff comes in. So, and I don't know if this will work once I switch this to an indirect either. It may get messy. All right. This should work for everybody. Oh, the tests that need field access will need to pull the fields from the info field, I think. No? Let me just clear those tests. Okay, I guess the tests all compared, since the items are equatable, they just compared full items, so they don't care about that either. So, okay, I think that's a win. Introduce connector info to hold fields. Connector to hold that. Okay, that seems good. Now, okay, so now connectors. Okay, I want connector 1 element returns empty. I think, okay. Connector, all right, let's try and do the enum thing. So like this, public indirect enum says this enum is allowed to recursively contain itself. So we're going to try that here. And I mean, I have to be able to put all these fields in here now. Okay. I have to do case. Yeah, those branches have centers, so that's why I'm hoping it does it. Okay, so now this is going to get messier. So it's going to be case element and sequence number. Yeah, I think just sequence number for now. And then case cluster. And it's going to need sequence number. Oh no, he's going to need, I think I'm going to lose my constructor that was so nice. I don't think I can put a constructor on them. Well, he needs connector info. All right. Now I can have these accessor kind of things. What I don't think I can do is, well, I can't have that. And I'm not sure it's going to like this either. No. I think I can I return myself? I may not be able to do this, so I may have wasted my time. Okay. Parend, another parend. Okay. Sequence number. This is going to have to be a switch. Info.id. Okay, so I can get that. Now this. Does this maybe need to know its row number? That'd probably be public if it's going to put it in there. Okay. Now center, this becomes switch self case dot element of sequence number. Well, we don't care about the sequence number. Row number. Yeah, I don't know. Sequence number. Oh, I can't do that. Oh, can I? Connector dot. It doesn't seem right. All right, I don't think this is doable. I think I'm going to have to adjust all those connector places. Goof. Okay, what's going on? All right, everybody that's going to complain, I mean, everybody that's a problem should complain. Connector cannot be accessed. Public indirect. Connector. Ay, ay, ay. Oh, is this a mistake? I don't know. I mean, I could define top and bottom. No. Well, yes. It's in the connectors. I don't know what you call this, attached information, but it's in there now. It's not a field. So connector.info doesn't make sense unless you peel it apart like this. But I mean, I could, top and bottom makes sense. I mean, I don't know. I'll put this here. Public var top of branch. Well, no, does he? Connectors. Level's okay because the elements all have 0 level. Oh gosh. So I'd really like to just say connector.top and know that this is only working on connectors that that we know are of that type. Now, maybe that can be done. Let's see who calls cluster here. Cluster of connector. Yeah, we won't put the other kind of connector in there, so ugh. Let's see. I mean, I can do this kind of thing. Element. Oh, what's the thing that makes it crash when you don't do something that just isn't doable? Crash here. Ugh, I don't want that kind of crash. Language. Fatal error. Yeah. I don't know if this is good. I'm going to go a little further down this path. I don't know. There ought to be some way to just delegate into that. All right, connector cannot be initialized. Okay, now we have to go back to connector info. Oh, sorry, connector dot cluster of connector info. And this reads better. Element IDs. I suspect it's complaining about these two. All right. Level. Element IDs. Well, I don't want to throw. I mean, that it's just really is a never should have happened kind of thing. I'm not totally happy with it either. If I start throwing, I have to make everybody willing and able to declare their throws and all that stuff, and I just kind of hate that. It seems like it's not really their business that somebody's going to throw if they don't have anything to do about it, but dot element. Okay, if it's an element, that one's actually meaningful. If it's a cluster with info, okay, I think I need level. I don't know. It's kind of like I want to get through it, and I still don't even know if I'm going to like it. Element level is always 0.0. And this is info.level. I'm missing one. Level ID branch. Connector.element IDs. Connector.level. Okay. Now I'm back to connector info. Connector dot cluster. Connector info. Maybe maybe this would benefit from that separate assertion method. Let's do that. Yeah, I would like to avoid it, but I don't know. The other alternative I see is I put all those fields in there in connector info, and I just don't want to do that. Yeah, this is a bigger change than I wanted to mess with. We have a cluster. Call this actual and expected. editor's supposed to turn those off. Okay. Okay, well, goodness. Make connector an indirect class holding a connector info when it's a cluster. Okay. So it's connectors that's going to be the focus. Okay, so I don't know if I can. Let's start. Yeah, cluster knows the info. Oh no, cluster doesn't know the connector. It's connector knows connector info. But yeah, I was kind of trying to avoid that. So I'm wondering if I can return. What if I return a connector and a list of connectors? Okay, I think let's take a break though. It's been over an hour. I think we'll come back and I think I'll start with this inner method. The outer one still is going to be looking for connectors, but we're going to make this one return a tuple, the pair being the connector we construct and the list of all connectors. And the only reason I'm keeping the list is that's what everybody else uses. We can modify them. We'll get that done in place here, then modify it here, make the callers, switch them over one at a time to use the connector instead of the list of connectors. And then we'll see where we're at. All right, so see you in 3 or 4 minutes. Welcome back. All right. So if this method returns a pair, I'd like to return a connector and a connector's E. Just connector's E. Where's that element being used? Is that? Oh, cluster of E. Okay, yeah, it needs that. Connectors of E, though. I don't think. Okay, I guess. All right. So let's make this, we'll say we want a connector and a connector's E. All right. So anybody, so right now we're only returning that second argument, or the second one of the pair, but each of these has to do one first. Okay, so he's going to return a element of cluster element has sequence number and E. Sequence number E, and we're going to return element of sequence number and connectors of that. Is that true? Connector element takes sequence number and row number. Well, we know the starting row, so that's good. Okay, so that's cool. All right, now center one, connectors one. Well, we're going to have to make this a pair to receive it. Connector one, connectors one. Hopefully I don't get confused by that. Connector two, connectors two. Right. And then this return. Well, he's going to be my connector. Let's call this my connector. And then we're going to return my connector and result. Okay, so nobody should care on this, I think. Right? Yeah, that's okay. We'll leave that for now. This is private, so all the tests are going through the real, quote, real method. Okay, and that means everybody should pass at this point. I mean, I guess I could put underscore in there for now. Reduce my confusion even more. Okay, so we make connectors.build return both the connector and the collection. Okay, now I think my point of all this is connector has a center, right? Everybody does a center. Okay. So so this case, we knew that center one, we know cluster one sequence number is in here because the construction of this is to put it in there. And so center one's type is double. Okay, I think he's really connector one. Okay, so connector two. All right, I think center one is connector 1 dot center. Okay, so all that work, yes, is going down to that. I think it'll do other things for us, but first of all, it's doing that. So let's center 2 equals connector 2 dot center, and everybody should be happy. All right. So use returned connector to get center. And this would have probably saved us earlier as well if we'd done it this way, but it makes connector has more complexity than it did. I guess that's okay. Connector 1. Well, I think I'm going to inline this to here and this to here. Okay. Right. Now, okay, so element, we're returning an empty list. Okay. All right. That should pass. Okay. So I know I'm making connector worse, but I think we're making this one better. And once we get rid of the list, this will be even better. But I think doing this, that makes that the natural thing to do, that we've got the connector, we know where to draw the top line then, because it's the center of the previous connector. It all just works out. Okay. Let's see, am I checked in? Okay, good. All right. Now, okay, so I don't think that's going to simplify any. What's all sequence numbers? Okay. We don't really need a cluster to get that. Cluster connectors. Okay. I think we're ready to move off this one and focus here. Let's see who calls this. Let's try the right call there. Well, not very many. Oh, this. Oh, gosh, I don't know. Am I going down a bad path? I like getting center from the thing directly and not having to run around to get it. So that feels good. This, I think for my drawing, I can't. I don't think I have a recursive way to draw, do I? And normally you do these for eaches and you're getting a list of things. I could get the list back out. I mean, maybe that would be better. I don't know. What build should return to it is the list of stuff. So maybe that would be. I don't know. I don't want to walk it again if I can help it. Connectors. Really, I want this. So let's do that. Array of connector. Okay, return connectors dot contents. Let's get the call out of here. That's a step forward. Now these build C1. That's going to be empty. They should be complaining. I'm not sure why they're not. Okay, build returns the contents. Actual is cut. So that's a connector. Okay, that's okay. And I'm doing this just to make it return what the caller wants instead of what was there. So I'm reducing, I don't know, connectors is kind of becoming pointless. I think connectors is pointless by now. So this thing's returning connectors of E. I think it should just return array of connectors. Okay, so this one is empty. This one is connectors.connectors. Well, connectors 1. Is an array of connectors. Can I do that? Oh, it's not that one, it's this one. Which really should have been the case anyway. Oh, I guess we had our object instead. Connectors 1, append contents, connectors 2. Result, but this should be array of connector. Yeah. Okay, so who's using this? Connectors. I don't think anybody's using these three now. I don't think anybody's using this either. So this doesn't matter. Let's make sure that's okay. There could be some test that's rolling on comparing connectors. Okay. All right. I think the method's going to move over somewhere else. That's what's really going to happen. Okay. That's no longer that. Okay. I think you could give connector this responsibility now. He only has that. He doesn't return that to use. Yeah, let's move this over to connector. Is that going to fit in there? I don't know if I can put it on the enum. Let's do this. Let's take one piece at a time. We'll turn this back private shortly. Let's make it. I think maybe if build connectors from cluster kind of method. Equatable, I think it's and hashable. Okay, so now who calls this? We'd like them to call build connectors instead. Connectors, tests. Let's see, we have connector tests as well. I'm going to rename this connector tests. Might be a test that needs it. Okay, and now this function is going to go down there too. Okay, and now connectors should be deletable. And let's do a clean build. All right. Okay, so we're still calculating. We're calculating this one and not using it. I don't think we can use it. Well, let's. We can't use it there, and we don't particularly want it here. So I think this is okay then. We do want it because we want it for this purpose. I thought we would want it for other reasons, but being a display thing, it really doesn't make sense. Oh my goodness. Okay. So let's see how Dendrogram views. He's still okay. What's our to-do say? Have we done anything today? Fix vertical spacing. Yes. Okay, and then we make build connectors in connector, deleted connectors, and build connector returns pair of single connector and list. So the former can be used to find the center, proper center, proper target for a top line. Okay, spread it horizontally. It would be better to have an explicit empty cluster. Notice the other thing we did not do, my connectors we didn't add the extra stuff to make them connect to the other connectors. Let's see, where is that? Up here. I had expected that this would need to know child 1, child 2 connectors, and it doesn't. If we wanted to not return the list, but just accumulate it from the whole connector, we could do that. And then cluster, what are you? You're still an indirect enum. Okay. All right, let's look at dendrogram view. I don't think we'll need proximity matrix. So what I dislike, and we saw the cost of that when things are upside down from what I want. Okay, so can I reverse these vertically? Well, I certainly can. The other thing that bugs me is this list comes from the cluster. This comes from the connectors, which originally comes from the cluster, to be sure. Well, yeah, I mean, we can easily flip it. Yeah, you're right. We can do that. Let's see that in action. Why these leaves are in the backwards order, though, I'm just lost there. And honestly, I think the flipping shouldn't even be necessary because we built our trees with row 0 and 1. They should be the most common. So I'm doing something somewhere we put stuff in that was 1.0 minus level, and now I'm paying for that with this confusing flip. But let's take the big set and cluster. Takes a few seconds. Okay. So, well, it's offset somehow. I don't know if the title is not being respected, but it is. Something's weird. Well, maybe we are just slid down. I would have thought. I mean, I thought the way we constructed this, that row 0 and row 1 had to be the most close match. Why this is not at row 0, I don't know. And if you remember air 7th, it was a long, slow one. Okay. But, oh no, that first one should be highlighting this. Is what, I don't know what this line is. Okay. So I don't know. There's more to it than flipping Y scale, I guess. I didn't expect that. Padding 4. Maybe this is not flipped. Oh, where's my flip? Sorry, that's not it. Height should be Y scale, yes. Padding Y scale /2. Okay. All right, what do we have? Horizontal stack of a Z stack and a Z stack. The last cluster was at the top. Yeah. This, to me, should be highlighting these two. But is that? I don't know. Boy, we've twiddled around on these Y scales and flipping and so much. Why it's drawing above the Z stack, that seems weird to me. Offset. Maybe this is an offset. It's got to be scale, right? Dot scale effect y colon minus 1.0. Let's try that. Yeah, that's a good question. Okay, it's off by 1 still. Maybe that offset is not appropriate. Okay, that's highlighting these down here. Yeah, that's more what I expected. I think the offset is throwing us off here. It says push us down one more row, and I think that's wrong. Yeah, I think it looks better with the closer ones on the top. I mean, these are backwards now. That's going to be the ones near air 7th. Did that highlight? Yeah, if I can flip the names. Unfortunately, the easy way is not going to do it, but it's drawing in the right place now. So that scale. All right, so let's say, are we doing this on to-do? Let's make sure we are. The flip. Let's do that. Okay, I mean, the cheap flip is going to look ugly. Dendrogram view. So if we flip these, y colon minus 1.0. I expect the names to flip too, so may not. Yeah, I mean, we've been back and forth on this. Originally, we had the names. I don't know. We had the other ones reversed because we were drawing on top of each other. Yeah, here's what I was afraid of. The offset needs to go away, but now the right ones are there, just offset by 1. Okay, let's take that off. Okay, well, maybe this should be offset down 1. Okay, but if the names were, well, I suppose I could, let's do it the cheap way first, right? We can, somewhere here we can scale. So, I mean, this is all should be unnecessary, but I think we'll get it correct. Now it looks like it's going to be offset a row or something like that. Names had a calculation with the count of the elements. Yeah, they're not doing that much. They're just there. Okay, so yeah, we're offset a little bit. Now we're flipped totally. I think if we put the offset back here, that puts us right. Well, maybe it's half. Okay, I think we're back to kind of where we were. They're a little cramped. You can see maybe it's not cut off. I don't know, but it's tight. Okay, these are the most common. Next most, next most, next most. I mean, this is. Okay, near seventh is the least like anything. All right. I think that's pretty good. I mean, we can fiddle with it. Okay, well, to your point, we know we had this reversed at some point. I just don't know why we need it reversed. Okay, and let's take. Yeah, I think it's down a little bit too much. Where's the scale? Oh, how weird. Well, that was the Z-stack bit down here, but I didn't think it was this. So I'm confused. This being reversed would imply that these would be on the top, right? If I hadn't reversed it? Maybe I'm... No. They're coming out in the same order regardless. Now that just seems wrong. Oh, there's Z-stack too. Oh. No, I don't get it. Yeah, it flips the drawing order. Well, no, it flips this number is used to figure out the row. um but they are a Z-stack, so the row is what determines it, not the order that they came out. So enumerated. Well, no, you'd think that would flip the numbers. Leaf sequence number. I've got these. Oh no, they're zero based. Leaf sequence number. But I think this gets back to my problem with doing it the way we're doing it, that I really would rather have a recursive drawing thing that took care of the children. I don't know. If if I do leaves done and everything, okay, now I got to pay attention to the contents. So the ending is 038 and the start is air 7th at 1. If I reverse it, the titles may stay the same, but the numbers should flip. Okay, so let's run it again. Oh, I'm sorry. It takes me so many times to look at these things and see what I got to see. Okay. Now this is 1. And that's 038. Those numbers are coming out the same. 127.28. So reversed is not doing anything. Oh, reversed is in the wrong place. I gotta reverse them before I count them. That seems to be better. And air 7th at the bottom. Okay, it is a bit cut off when the diamond's right there. Okay. That's the order I want them. Why they're not coming in that order, I don't know. Yeah, I think they're flipped. Why I still don't understand why we have to reverse them, but regardless, this is the order I expect them because these should be the most similar stuff. Now, these two are very similar. These two are even more similar. And this is a distance metric, so the shorter ones are the closest matches. And these, now they get taller and taller out here. Yeah, I mean, if you put a cutoff somewhere, you'd see that those are much less likely to be related. And I think we scaled it horizontally, so this is 1. Okay, so I'm gonna fiddle with the placement. This has to go up to, maybe this goes down 1. I had a little space before, but after the title, so pull this down 1, pull this one up 1. I think we'll be lined up. Okay, so that can, oh, okay, that's down 1. Y scale minus should be up 1. But this mismatch captures exactly what I'm not liking about this, because they get drawn completely separately. You know, my natural situation would be if the connector, if I had the element connectors like I sort of have, this connector would be drawn here, and the connector would say, oh, you're an element connector, just draw your name on the proper row. You know what row you're in, and draw it there. That may be I don't know, that may be worth doing. All right. And then X, I want to offset it a little horizontally. We're still not right. This, I think if this went up 1, we might be okay. Is that what I want look-wise? Yeah, I can get it another way. Okay, so offset Y scale, I'm going to take that off. Okay. Yeah, I mean, I think, we haven't spent tons of time coordinating those, but the fact that we need to is a sign of something. I don't it it would probably be better. Maybe I can figure out how to do the recursive thing. Otherwise, I don't know. All right. I think those look like they're pretty good. Should be kind of in the center of the line, and I think that's about right. Okay, so let's take our whatever level of win. I don't know, maybe I can. All right. That we still have to deal with. Okay. Let's make sure I didn't mess up any tests. I don't see how I could. I'd also have to get the name into those fields somehow, so that would be another little bit of a challenge. All right. So flip the drawing, flip the dendrogram, so the best cluster is on top, worst ones on the bottom. Okay. Okay, how much? We got a little bit of time left. All right, let's do that. Some more objects on top. Okay. I think space-wise, I can make that title, give it a little padding if I want to keep them separated out a little bit. I don't know if it comes through the mic, but my grandchild is not happy. Okay. I think if we gave him 4 pixels or so, he'd be fine. We might already give him some. Cluster, there's the title. Okay. It's a little better. Okay. I might make it 8. Well, how did it look on top? Maybe I'll say bottom. Yeah, I think that works. All right, so all right, so I guess the two ways to tackle that. One would be let's find out why we have to do reversed if we can. Somebody may be reversing it already. Nope. Okay. Gosh, I really don't understand. I mean, cluster 1 should be the... yeah, so this is the order the leaves are coming at us, and then they get their enumeration, which tells them what order to put the line number. So what I thought was the way we clustered and the way we built things, the leaves would always come out with the most, their natural order is row 0 is the most, row 0 with row 1 is the most dense cluster, the best cluster. And that is not the case. Now, cluster.leaves, right? So what he does, if it's a cluster, it takes the leaves of the top one first. Y scale is it's the width of the height of the text plus some spacing. Let's see, it's up here somewhere. Y scale is font size times line spacing, and I think line spacing is 1.5 or 2. Okay, so it's kind of twice the height of this thing, of each line. Okay, but it's like the more I look at this thing, the less I feel like I understand what I did in the clustering. I thought that child 1 would be the close cluster, and then the first two would be the close cluster, and then we would add. So this, in the next cluster out, this would be the top and this would be the bottom. So the top is always the better cluster. In a way, that's well. What's weird to me, like this one to me, is left of this one, which that may just happen from sort of arbitrary ordering, I guess. I'm going to have to go back to our algorithm. I think we have it here. Yeah. Okay, we start off with everybody in their own cluster. We find the most similar pair. Okay. Yeah. So the first time through, this is the most similar pair. Maybe it's a tie, but we pick one. And then this one. And then this one. And is there any more duplicates? And this one. Then the most similar pair. Well, gosh, that looks like this one. Or is it? I guess, yeah. Yeah. But like this one to, 39.0 to 21, I think this horizontal distance is, these look identical. I think they're both exact matches. And this distance is longer than this distance. So that would make it seem like this one was the best matched. But maybe not, because they might be best matched, but they're relatively far away from this. And then this one is joining those two clusters. I don't know if the net similarity, because like some of it is like this distance is so small, right? It's like, yeah, you're closer. I'm not sure. I don't have enough intuition about the algorithm. Yeah. among other things. All right, so I'm curious, like, why they were exactly backwards coming out of this thing. And this, I thought the top being cluster 1 was always the better cluster. And so this would be in the right order, but it seems like it's backwards. I've got something is coming together backwards. I'm not sure why. Union. Okay. That's fine. It's kind of a hard way to do the union. You would think there'd be a union that worked in place. Is that form union? Cluster 1, cluster 2 on line 21. Here? Yeah, I mean, I can swap them, but no, wait a minute. That's all sequence numbers. That doesn't matter. That's a set union of the two. It's really this leaves that counts. Now, elements and leaves should be the same. Elements is the contents of the cluster. Okay. So if I swap them here, I mean, I'm saying, well, cluster 2 was the first. I'm saying this cluster is the last. So I got to find who creates this, right? Yeah. I guess we're saying here's what we think would do it. Cluster 2, cluster 1, run. I do think it would do it. I just don't see why it should be necessary. But it may be like where I build the cluster, maybe I got it flipped. Yeah, there's air 7th on top again. Okay, so, and we have the reversed. So, yeah, so we're not building them this way, the way I thought we were. That would be proximity, I guess. Okay, so let's just find dot cluster, cluster 1, cluster 2. See best pair. Well, do you know? It's, I don't know if this is almost, yeah, that's a good question too. I don't think so. Okay. Let's find our distance function. Where is that? Is it in here? No. Tune distance. Parsons 1 symbols, Parsons 1 distance. And this is symmetric, so I don't think there's an issue there. Let's see. Cluster 1's find sequence number. So I don't know. Best pair seems to be, I mean, in a way, the best pair is not. I guess it is ordered because this filter. Yeah, that's a good question. Okay, I think we flipped it here. So the score is, it's always 0 to 1. So I think a 1's a perfect match, so 1.0 minus that. But maybe that's a place to start looking. Okay, well, we're going to wrap up today. But let's check Parsons code to make sure it's not flipped. I guess that's a way to say it. But I'm pretty sure. Whoops. Well, these two on the bottom, and they're equal. 0 and 38. Yeah, you're right. Yeah, that may be the thing. So we'll start there tomorrow. I don't know if I've left. Did I leave things swapped? What was that? Oh shoot, where's that calculation? It's not dendrogram view. Leaves. Okay, I'm back to 1, 2. Okay, so we'll pick up there tomorrow, 2 to 4:30 p.m. Eastern, 6 to 8:30 p.m. UTC, and I mean we're closing in on it. We've got a solution. I think we're working towards a better solution. There's too much flipping going on. Oh no. So tomorrow and Thursday we'll do this. We have too much flipping going on and it's catching us. So we're gonna simplify some of those. There's a comment, what's his name? James Blinn that did all the planet flybys and stuff. And he's like, you have to carefully follow the signs flipping and then, then look at it. And if it's wrong, flip it one more time. And I feel like we've been kind of in that mode. I want to get it so simple that we don't need to think about the flipping and go from there. So anyway, thanks again for joining today and Mudshark and for anybody else, and catch you tomorrow or sometime in the future. Bye-bye.